In the 1950s, the word artificial intelligence meant something very different from today. Picture a giant computer room filled with humming machines while scientists type simple instructions. If this happens, then do that. No learning, no creativity, just strict logic. Yet those small, methodical steps lit the path to the self-learning systems that now write stories, create art, and make decisions on their own. To see where AI is heading, we first need to travel back to the moment it began. Step 1. Rules-based systems. Early researchers believed that carefully written instructions could make a computer think. They built rules-based systems, programs made of thousands of if X, then Y statements. One of the first famous examples was ELIZA, created in 1966 by Joseph Weizenbaum at MIT. ELIZA acted like a psychotherapist by turning a user's words into questions. If someone typed, "I feel sad," it might answer, "Why do you feel sad?" The program didn't understand emotions, but many users were convinced it did, showing how easily humans project intelligence onto a machine. By the 1980s, these experiments evolved into expert systems. Companies used them to troubleshoot equipment, and hospitals tested them to suggest treatments for infections. Investors poured billions into the idea, expecting it to transform industry. But these systems were brittle. If a situation fell outside the coded instructions, they failed. Writing rules for every possible case proved impossible, and by the early 1990s, the expert system boom collapsed, proving that real intelligence required more than an endless list of if-then commands. Stage 2, machine learning emerges. The next breakthrough came when scientists stopped telling computers exactly what to do and instead taught them to learn from examples. This approach, called machine learning, became dominant in the 1990s. Instead of listing every keyword that might signal a spam email, engineers trained algorithms on thousands of real messages so the computer could find patterns on its own. As spammers changed tactics, the filters adapted, something rule-based systems could never do. Machine learning soon powered recommendation engines, the kind we still use today. When Amazon launched its "customers who bought this also bought" feature in the late 1990s, it was using a technique called collaborative filtering to study buying habits and predict what a shopper might like next. Around the same time, speech recognition began to improve. In 1997, Dragon Naturally Speaking became the first consumer software able to handle continuous speech, giving a glimpse of what could happen when more data and faster computers met smarter algorithms. These systems were far more flexible than their rule-based ancestors, but they had limits. Early machine learning models were narrow, good at one job and useless outside it. They needed the next leap, an approach that could handle massive data sets and discover complex patterns almost like a human brain. Stage 3, deep learning revolution. That leap arrived in the 2010s with deep learning, which uses layers of artificial neurons to process information in stages. Deep learning took center stage in 2012 when a team led by Geoffrey Hinton at the University of Toronto shocked the research world. Their deep neural network competed in the ImageNet contest, a massive challenge to classify millions of images into categories. The result was dramatic. Their system cut the error rate by more than 40%, a breakthrough that signaled a new era. Suddenly, computers were not only spotting simple patterns, but recognizing complex images with remarkable accuracy. The cultural buzz grew when Google trained a neural network on 10 million random YouTube thumbnails. Without any human labels, the system learned to recognize cats on its own. No one told the computer what a cat was. It discovered the concept from pure data, showing the world that machines could form ideas beyond explicit programming. Deep learning soon transformed daily life. Between 2014 and 2016, speech recognition systems like Apple's Siri and Google Voice improved from frustrating to genuinely useful. Translation leapt forward in 2016 when Google introduced neural machine translation, making cross-language conversations far smoother and more natural. And in the same year, DeepMind's AlphaGo defeated world champion Lee Sedol in the ancient game of Go, a feat long thought impossible for computers because of the game's immense complexity. AlphaGo did more than win a match. It proved that I could master strategic reasoning and long-term planning, skills once believed to be uniquely human. Through the 2000s, TEN's deep learning dominated AI research. Yet these systems were still narrow. They could crush a board game, identify faces, or convert speech to text, but each network was trained for a single purpose. A chess model could not suddenly translate languages. To move forward, scientists needed AI that could learn once and apply that knowledge to many different tasks. Stage 4. Generative AI and foundation models. Around 2018, a new idea took hold. Build enormous foundation models trained on massive amounts of general data, books, websites, images, and then fine-tune them for countless jobs. This shift led directly to the tools we use today. In 2019, OpenAI introduced GPT-2, a language model able to write paragraphs that read as if a person had composed them. A year later, GPT-3 arrived with 175 billion parameters, showing that a single model could translate text, summarize articles, answer questions, and even write computer code. Other research groups followed, and soon generative AI was everywhere. Images joined the revolution. In 2021, OpenAI unveiled DALL-E, which could create pictures from text prompts. In 2022, Stable Diffusion made similar technology open source, sparking a flood of AI art across social media. Tools like Midjourney quickly became cultural phenomena. Soon, text-to-video and text-to-audio systems appeared. By 2023, Runway's Gen 2 and Pika Labs demonstrated short video generation from simple written descriptions. OpenAI's Whisper improved speech recognition, while its 2024 release of Sora showcased realistic long-form AI video. By the mid-2020s, generative AI was no longer a lab experiment. Microsoft integrated GPT technology into Office as Copilot. Google launched Gemini to compete. Adobe added Firefly directly into Photoshop. Millions of people now use these tools to write, design, and create every day. Yet these powerful models do not truly understand the world. They predict patterns based on training data, which is why they sometimes make errors or hallucinate facts. They open new possibilities, but they also set the stage for something even more ambitious: AI that can plan and act on its own. Stage 5. Autonomous agents. The next leap is happening right now. Instead of just answering prompts, autonomous agents plan, decide, and execute tasks with little human help. In 2023, experimental tools like AutoGPT and Baby AGI gained attention for chaining multiple AI steps together to reach a goal. You could tell AutoGPT, research the best headphones under $200 and create a report, and it would search the web, analyze results, and deliver a document without further instructions. By 2024, companies pushed the concept further. Cognition AI introduced Devin, promoted as the first AI software engineer. Given a high-level instruction, build a website with a login system, Devin could handle coding, debugging, and deployment in a single workflow. Similar agent technology is now tested in customer service, finance, and robotics, where language models control physical machines and connect reasoning to real-world action. These advances bring fresh challenges. Who is responsible if an autonomous agent makes a costly mistake? How do we ensure these systems follow human intent and remain safe? Such questions lead directly to the next horizon of AI development. Stage 6. Toward Artificial General Intelligence. Researchers now aim for Artificial General Intelligence, AGI, a system that can think and learn across many fields at a human level or beyond. Unlike today's narrow models, AGI would transfer knowledge from one task to another and adapt to new challenges. Some experts, including leaders at OpenAI, predict AGI could appear within the next decade. Others argue that current large language models still lack true reasoning and real understanding. Pioneers like Geoffrey Hinton have even left major companies to speak openly about the risks, warning that progress might move faster than expected. Stage 7. The idea of superintelligence. Beyond AGI lies artificial superintelligence, ASI, a stage where machines surpass human intelligence in every area. If an AI can reach human level and then improve itself, it could quickly move beyond our control. Governments and companies are already preparing for that possibility. In 2023, the United States and European Union began drafting global safety rules, and by 2024, more than 20 nations signed agreements focused on AI oversight. The potential is enormous, from solving climate challenges to discovering new medicines, but the responsibility is just as great. From simple if-then commands in the 1950s to today's self-learning systems and the dreams of superintelligence, every step has built on the last. Rules gave us structure, machine learning gave us adaptability, deep learning gave us scale, and generative AI gave us creativity. The next leap could arrive sooner than anyone expects. Thanks for watching. Share your thoughts about AI's future in the comments, and subscribe for more documentaries exploring the technology shaping our world.